Hello, and thank you for tuning in to my very first video on YouTube. This video will be about SAP 2000, and I'll just be doing a little run through with the software slash a Truss example. As a undergrad civil engineer student, I really like SAP 2000 because with all the hand calculations you do in class, you could always confirm your answers by throwing it into SAP 2000 and see if you get the same result. So yeah, let's run through it. First thing you want to do is go File on the top left here, click on New Model. This will show up. We're going to keep everything at default, so default units kilonewtons meter, default material United States, and for the select template we'll pick grid only. So in the x direction, number of lines, we have 1, 2, 3, 4, 5, according to the example. X direction we'll put 1, because I want to say something weird happens if you put 0. And Z direction we will put 2, because we have one at the bottom and the top. Grid spacing, we got 5 meters between every joint, or every line on the x-axis. Y direction we'll throw in a 1 again, and the Z direction is separated by 5 meters every time. And the first grid line location is at 0, which means we're at the origin, so hit OK. We get something like this here. I'm not too concerned about this 3D view since many problems of trusses are dealt with in 2D. And then we'll change this view to XZ. Alright, we'll define materials. So when you define a material, you want to add a new one. We'll keep everything default. And we'll modify it. And by modify it, we'll just change the name to steel material. We'll keep the material weight default, the modulus of elasticity default, and the units already match up, which is perfect. Hit OK. And there we go. We just made a material. Hit OK again. And now we will make a section property. So go to Define, Section Properties, Frame Sections. And then we'll add a new property. And what property does is it deals with the cross-sectional area of the truss member. So since we don't really have a shape assigned to it, we'll go to Other, and then we'll click General. We'll keep it as default as well, which is 1, and we'll hit OK. The section name, I'll call this Steel Section. And then on the material, we'll put steel material. So that means it will have the same weight and the same modulus of elasticity as we assigned earlier. Hit OK. Hit OK again. Alright, now we got our material set. We could start building our truss. The first thing you want to do is make the joint. So you'll go Draw on the top here and draw a special joint. Or you could go on the left, but we'll just stick with this here. Click on every joint, just as it would look like on the truss example. And then you want to draw the cables, or the truss members. So draw frame / cable, and then just connect every single joint, just like it is in the picture. And then when you get stuck here, just gotta right click on your mouse and then just start drawing again. Then right click, then start drawing again. Perfect. Hit escape to leave the draw cable. Next thing we will do is the restraints, or the reactions, or the support, sorry. So you'll want to click on the bottom left joint. We will assign it a restraint. So you hit a roller. A roller is only allowed to move in the, or is restrained to move in the up and down direction. So just click on the roller And there you go. It'll show that it's restrained to translation 3, which is the z-axis. Hit apply. And there we go. We got a little roller on the bottom left. If we do the same thing for the bottom right, which is where the pin will go, assign joint restraint, hit a pin. A pin can't move in any direction, so hit apply. And there we go. Alright, next thing we'll do is assign the loads. So we got a 50 kilonewton load at this joint, so click on the joint, assign joint loads, forces, -50, hit apply. You'll see that small downward arrow there, which is good. We'll do the same for the 25 in the downward direction. And we'll do one for the 60 also in the downward direction. Perfect, we're almost there. Another thing about many truss examples is we don't consider the weight of the truss members itself. So load patterns, self-weight multiplier is 0. Hit modify load pattern. There it changes it to 0. Perfect. And then the last thing we want to do is that SAP2000 assumes that the truss member that we built is a frame. So what we want to do is we want to make it separate truss members, and we'll do that by highlighting the entire truss, assign, frame, partial fixity, and what it will look like by default is this most of the time, blank boxes, and then you want to check all of them on the bottom 4, sorry. Apply, and what that will do is it will separate the joints, but sometimes it'll just show the green dots and not separate it, but either one will get the job done. Next thing is you'll notice that the loads are missing. Just got to right click on the load, just double check that they're still there, which they are, and now we can run this thing. So click run at the top here. We want to analyze the dead load, hit run now, and we'll save the truss. And there we go. This is the result we get. 0 errors, perfect. So what this means is every member that is blue is under tension, and every member that is red is under compression. Also, this one here is the axial force diagram, so this is what the truss members are feeling, or the loads that they are subjected to. And I'll show you what the reaction forces are. So we'll click on this one here, show forces / stresses, go to joints, and we'll hit arrows. And what that does is it shows the arrow in the direction in which the reaction forces are acting. So this makes sense. 65 acting upwards, 70 acting upwards, so that's good. And lastly, we will show the deformation of the frame, or the truss. So we'll click on the one beside it which says show deformed shape. Looking at all these here, draw contours, which is what we want. Perfect. Hit apply, hit OK. And yet this is what the frame would look like if it were subjected to these loads. Perfect. So yeah, thanks guys for tuning in. I'll definitely do more examples that are a little more complicated, that will require a couple more inputs on SAP 2000. So yeah, just tune into those, and thank you for watching.